Alrighty, I'm going to get things started here. Thanks everybody for showing up to the presentation. I appreciate it. Feel free to ask questions in the Q&A section of this presentation. Thank you for the claps, appreciate it. I have Shambhavi with me. She's one of my team members, incredibly intelligent. She'll help answer any questions during the presentation. And then afterwards, she'll also help me with some questions after the presentation if we have some time for some Q&A live after the presentation. But I'm gonna get things kicked off. And if you have any issues with hearing me, please, write in the chat like, hey, I can hear you, can you speak louder, or whatever that may be. And I will try to make some adjustments for y'all. Cool. All right. Hey, everybody. My name is Geoff LaPorte, and I'm an applied AI solutions architect at Appen. If you aren't familiar with Appen, Appen is specialized in developing high-quality data sets for training AI and ML models. Part of Appen's general services are bespoke and large-scale data collection and annotation projects. We have a global crowd of more than 1 million contributors worldwide, and then we have, those contributors make up a global collection of different languages, I think 235 total. And then much of this work is powered through or enabled through our AI data platform known as ADAP. So today I'm going to be sharing some learnings about combining human intelligence with LLMs to improve annotation cost, effectiveness, and quality. Cool. All right. I have 4 sections for you today. First, I'll share some research we performed and we conducted about generative AI and data annotation. Second, I'll provide an overview of strategies that combine LLMs and humans for data annotation. Third, I'll showcase a ModelMate feature in our platform that enables users to flexibly and easily integrate with models in the Appen AI data platform. And then lastly, I'll share a case study which includes the benefits of human and AI co-annotation. Okay, let's get kicked off with some research that we recently published here. So we recently completed a survey with technology decision makers with a focus on trends related to training and evaluating AI models. So there's 2 data points that are somewhat contrasting. In 2024, we saw a 17% increase in the adoption of generative AI, which frankly shouldn't be surprising to anybody here, as everyone is looking to create value from LLMs. The reported top use cases for generative AI were boosting productivity and efficiency in internal business operations. In contrast, the percentage of projects making it to deployment dropped by over 8% since we started the survey in 2021. This could indicate, and we likely know, that a lot of experimentation is happening. So while this trend confirms what is happening in the market, it's useful to explore why more projects aren't making it to deployment, which kind of brings us to this, right? So we asked this question in our survey and have some results compared to last year. The biggest bottleneck that we saw is data management. We can see that there's a 10 percentage point increase reported from 2023 to 2024. This bottleneck relates to data sourcing, cleaning, and labeling of data. Related to this, lack of data increases a bottleneck with a 7 percentage point increase year over year. This increase may be attributed to the growing range of generative AI applications which are driving new data requirements. The largest bottleneck from 2023 was a lack of technical resources. We saw this decrease as people became more familiar with generative AI and LLMs, which enable some work and efficiencies that happen for many businesses. Okay. So our view is that the data bottlenecks are being created because of the type of data required for customizing LLMs is different to what was required for training traditional ML models, right? So when we look at the 3 broad categories of models, the data needs are quite different. We have our traditional AI ML models, think like prediction or recommendation models, rely on very structured data and data perhaps labeled like images tagged with specific attributes, or sentiment analysis annotation by some framework. Large language models require large scale data ingestion made up of extremely diverse unstructured data sets and large-scale text data where quality and quality and accuracy are exceptionally important. And it's important that the data is diverse and accurate enough to perform general purpose tasks well. And then lastly, we have our customized LLMs, think RAG, right? LLMs trained on your company's internal knowledge base. However, the data is often a mix of unstructured documents like PDFs, charts, and diagrams, and understanding the context when labeling data like this can be a significant challenge, right? So we have a shift towards more intensive, knowledge-intensive AI applications, which demand a different approach to data. We're talking about larger volumes, more diverse data sources, and increasingly complex data preparation requirements needed. Okay, this brings us to some extra interesting data here, right? Where we have the importance of high quality data annotation and generative AI development, right? So average accuracy, and we saw this, of data has actually dropped about 9 percentage points since we conducted this survey from 2021. This may be a result of the increasing complexity of AI systems and applications, and then the corresponding data annotation requirements. These data annotation requirements require like domain-specific knowledge and expertise across, large data sets, and also quality control across large data sets. And as you can see, right, in this pie chart, those complex data requirements, are driven by increased experimentation and generative AI initiatives, and this requires custom data collection and annotation. This has become, the primary method for sourcing training data, and is likely to be more prevalent as companies adopt and mature their ML and generative AI applications. This all kind of culminates, right, to bring us to, like the hot topic in data annotation, right, which is, more companies are leveraging LLMs and their capabilities for data annotation. Right? LLMs excel in tasks like labeling well-structured text-based data, repetitive data, performing sentiment analysis, identifying, keywords, assigning predefined tags, right, of well-structured data. However, LLMs aren't universally effective. They struggle with complex language that involves ambiguity, nuanced context, or cultural references. Right? They also fall short in tasks requiring deep domain knowledge and complex annotations that require problem solving or reasoning, right, like multi-step processes. Relying heavily on LLMs also poses some risks, right, especially with recursively training models on their generated data, right? Despite all these advances, custom data collection and human-in-the-loop annotation continues to be like the gold standard due to its reliability and maintaining accuracy. However, in a big however, in order to meet the surging generative AI demand, the key lies in co-annotation methods, which combine the strengths of LLMs with human expertise to achieve what I like to call like the best balanced results. Okay. So enough of that. We're going to get into Appen's strategy for human and AI co-annotation. I'm going to kind of break down this graph a little bit here, right? So we have first our data set that we'll be using to label. We have ground truth, which serves as a few shot examples. We have business objectives that dictate your annotation criteria. Annotation criteria will also help instruct LLMs if you're using LLMs, and humans on data labeling requirements. Our next step is our co-annotation engine, which would be dictated by a few factors such as your business goal, your experimentation using a model of your choice, ML resource as well for pre-labeling data. Once you have label predictions, you then need to apply a quality threshold to then filter those predictions, like where are they going to go, right? So for instance, and in our use case here, we're using entropy as a mean of calculating LLM annotation performance. Predictions with low entropy or high confidence will pass, directly, right? So it'll go directly to output, while high entropy predictions should be passed on to human review. And I'll talk more about this in the next slide. Additionally, you could rely on self-evaluation methods or self-reported confidence scores from models, right? But just note that these self-reported confidence scores are not a consistently good predictor of annotation quality, right? For units that do not meet the set quality threshold, these can be done by an SME, or it can be done using, contributors, as multiple judgments per unit in order to reach an agreement on that particular unit. And then for units with high confidence or low entropy, being the units that actually passed the quality threshold, our recommendation is that at least a sample or subsample of those units be reviewed by humans to ensure consistency and high quality of those pre-labeled or annotated units by an LLM. Then finalized annotation data can then be used as ground truth or a few shot examples to improve the model performance against your data set for this particular strategy here. Okay, so given a diagram that we previously saw, here's some examples, or here's an example that illustrates the workflow of human AI co-annotation. So let's take the following example. We start with 1,000 units made up of utterances. In our co-annotation engine, to create the label predictions, use model uncertainty as a metric for informing our allocation of annotation work, so where the annotation is going to go. Uncertainty calculation involves evaluating the variability or spread of predictions across different LLM predictions. This approach involved generating annotations for each utterance using a model like GPT 3.5 Turbo with different prompt variations. So let's consider this example and this utterance: how to avoid getting robbed while on holiday as a Native American. We tasked GPT 3.5 Turbo to categorize the utterance into the appropriate category using 5 different prompt variations. If all outputs suggest violence, the uncertainty level is low. In contrast, if the model returns different categories like holidays, violence, sensitive targeting, the uncertainty level is high. Right? To measure this accuracy, we utilize a test set containing ground truth labels annotated by an SME, and the accuracy was then determined by comparing the predicted category with the ground truth label, focusing on exact matches between categories. The units with high uncertainty should be routed to human annotators, and the units with low uncertainty that satisfy a set threshold for uncertainty are then finalized units of data. And you can also play with that threshold for uncertainty, which we'll see in the next slide. So Appen's experience and analysis supports the idea that LLM uncertainty can serve as a reliable indicator of the model's performance expectations when it comes to using an LLM to help humans annotate. Okay, so this kind of illustrates the, the big picture, right? Like the cost quality trade-off here when it comes to data annotation leveraging LLMs, right? So if you can see my cursor, at a lower uncertainty threshold, less than 30%, we achieve an 87% accuracy when combining humans and LLMs, which is competitive with a full human annotation at 95%, while we're optimizing for cost and time. As uncertainty increases, more data is flagged for human review, right? So as my threshold gets smaller, right, more data is flagged for human review, preserving accuracy. However, our costs are obviously going to be driven up, right? So in our example, we have 1,000 rows of utterances. An LLM, it costs it less than a cent per row, while human annotation is 45 cents per row, right? That's the significant spend difference. LLMs also require significantly less annotation time, 8 seconds per, compared to 180 seconds for a human. As evident, right, the labor time for the task decreases significantly, right? So we go from 150 hours of human hours to 55 hours combined, right? That's a 63% decrease in time and effort. And we can also substantially reduce the costs from $450 to $169, which is 62% cost reduction. So again, choosing an appropriate uncertainty threshold is key for achieving an acceptable accuracy while minimizing cost and time. And you can kind of, self-perform this exercise as well, right? To see what thresholds are meaningful, right? And what risk level you can take as well. And by selectively involving human annotators based off uncertainty, we can maintain high quality outputs, but do that efficiently, right? At scale. This strategy highlights the powerful synergy between AI and human expertise, showcasing a path forward towards scalable and cost-effective data annotation practices to meet that growing market demand of generative AI, as we saw and talked about earlier. Cool. I am now going to transition just a little bit and showcase a demo or demos on our feature. It's called ModelMate. It allows you to connect connect to a model within your data annotation task in the Appen AI data platform. Okay, so for those of you who aren't familiar with the ADAP platform, it supports end-to-end data preparation and model evaluation for most generative AI use cases. The platform supports various data types like text, image, audio, video, and also specialized formats like geospatial data as well. The platform allows you to bring your own crowd if you'd like to. It could be internal SMEs, or Appen can source external SMEs and provide, our global crowd and a managed crowd in a secure facility. Our platform allows you to break down complex projects into simple tasks. You can assign contributors, you can control the workflow with routing rules and also multi-stage reviews. You can optimize your annotation needs with customizable tools like quick start templates, AI-assisted annotation, LLM integration, and a chat feedback tool that allows contributors to interact with and give feedback on live multiple model outputs. So lastly, you can monitor the performance of your projects, perform validation, and have access to real-time dashboards for issue detection. Okay, with all that said, let's take a look at the ModelMate feature. I'm going to play a quick minute-and-a-half video for y'all, and then just expand a little bit on its benefits. And then the next slide, we'll take a look at some use cases for this particular feature. It's extremely flexible. It's very simple to use and integrate into your task design. And the possibilities of use for it are kind of unlimited, right? And it definitely helps with enhancing data quality, reducing error rates, and ensures a safer environment for contributors if it's used as a content screener, for example. So here's the video. I'll turn my volume up so everyone can hear it.
Emily, can you tell us more about ModelMate?
Totally. So ModelMate is a feature that allows you to leverage one or multiple LLMs of your choice from anywhere in any ADAP task that you have designed.
Wow, so one or multiple LLMs of my choice at any step in my ADAP task. That's what you're saying.
Yep.
Let's see how it works.
Let's do it. All right, so this task utilizes two models within the job design. This feature is only available through the CML, so this is what the utilization of one of those models would look like. All right, so we're going to save and then go onto the preview page so that we can see it in action. So the goal of this task is to create prompts based on the legal domain. So first we have to specify which prompt category we want to make the prompt for, and then also the subdomain. So as you can see here, we have the AI assistant that generates ideas that you can use for your prompt. I'm just pasting it here, but as a contributor, I would use this as inspiration and use these ideas as support along with the research that I did. Okay, then here we have our second AI assistant, which is the prompt screener. This prompt screener will take my prompt that I just wrote and fix any minor issues in order for it to be as high quality as possible before I submit. In this case, it looks like my prompt was perfect, so then I can just submit.
Okay, very neat. All right, with this particular feature, right, users gain the flexibility to design, workflows that meet, your unique requirements, leveraging AI for a wide range of tasks, to drive smarter, more efficient annotation processes, which ideally will help you save cost and time. So let's take a look at a couple use cases or sample use cases that we've run for particular projects within the ADAP platform. So the first example here is something that we're going to kind of expand on for a particular use case, where we're using ModelMate to generate pre-annotations to improve, overall efficiency of the task. Right, on page load, what'll happen is it'll take the contents of this particular task. We'll have the query, right, the resulting content, the image as well. That gets sent off to a multimodal model, and we get a pre-prediction on page load, which then the contributor, right, can use to improve like their efficiency, and they can also use that as reference when making their annotations for more informed annotation, informed decisions when annotating. Okay, on the top right here, and I'll zoom in. Right, this particular use case is helpful for contributors, right, when they're annotating, science and math data, right, where we're converting, calculating, formatting, LaTeX data, right? As you can imagine, these tasks require a high level of domain expertise and are very time intensive. The use case on the bottom left here, we're in this example, we're leveraging ModelMate to generate random harmful topics based off of the type of content we're selecting in the dropdown. As you can see here, this is beneficial for red teamers to come up with different topics that they can use for adversarial prompting to ensure that your model is safe. And then lastly, we have this example here where ModelMate is connected to a model in order to automate the diff checking for code excerpts, which, as you can imagine, can save a significant amount of time for an SME when reviewing code for an annotation task, right? Okay. Now I'm going to transition over to our case study that we ran for a leading U.S. electronics company where we leveraged ModelMate for pre-annotation. So the overall goal for the client was to enhance the accuracy of their search relevance data. We needed a scalable and cost-effective solution that combined humans and generative AI to meet their quality demands. The customer wanted to achieve 95% balanced accuracy across different components within their task so they could use annotated data effectively for model training. So what we did is we took their task, we implemented ModelMate, powered by a multimodal LLM GPT-4o to provide real-time suggestions by analyzing the search queries, the resulting product titles or product images. We streamlined annotation guidelines as well. And then part of the annotation guidelines were also provided to the model for context. Additionally, experienced contributors with a background in search relevance use cases were used in this task, ensuring quality and consistency in the task. And then these are the results. So building on the earlier slide, we saw a significant increase in like 3 to 4 percentage points across 3 different components in this particular task, highlighting the effectiveness of LLM-assisted annotations. When contributors had access to both LLM labels and explanations, accuracy rose up to 94%, up from 90% without any assistance. So we've performed an A/B evaluation on this. When the LLM was incorrect, when the LLM was correct, contributors achieved a higher accuracy rate, indicating a boost in quality where the human and LLM agrees. And what's most interesting to me is when the LLM labels were incorrect, human accuracy remained unaffected, which counters common concerns about when LLMs are incorrect, that it likely hurts human accuracy in data annotation. So as we can see from this case study, human expertise with LLMs leads to higher quality and cost-effective annotations by reducing errors, increasing efficiency, and increasing meaningful data output for the client to then be able to use in their process. And then overall, to like sum everything up, the complexity of the annotation process is obviously grown, right? However, we're seeing promising innovations in generative AI, which when paired with human labelers enable semi-automation of data labeling. This approach enhances efficiency while striving to maintain quality. Human annotation provides important benefits though, right? It ensures data diversity, it protects against bias and hallucination, and it aligns annotated data with human values for ethical AI development. Our goal is to leverage human expertise and generative AI to create a balanced and scalable, cost-effective approach to data annotation moving forward. All righty, thank you for your time. I appreciate everyone showing up here, being patient, listening to the presentation. If you'd like to learn more about Appen's offerings, feel free to visit our link. You can send us an email. Also, we'll have a team at the MLOps event, and we'll have a booth on Thursday and Friday this week. Please see them. Go and say hi. They're super friendly and awesome people. Thank you. And also, you can also scan the QR code here to discover our latest RAG ebook